Okay, we're going to take a look at the next section in our electrochemistry unit, which is called electrochemical cells. Now, this is definitely an extension of our previous knowledge on electrochemistry, so we have to be really familiar with redox reactions, what oxidation and reduction are, as well as we have to be very familiar with predicting reactions in terms of determining an SOA and SRA, and looking at the type of reaction that's happening there. So essentially, an electrochemical cell is a device that continuously converts chemical energy, now that's important, into electrical energy. Now, again, just like the conservation of energy laws that we know, that we cannot lose energy, but we can convert forms. So we definitely convert a chemical energy into electrical energy. Now, a battery is a series of cells that's connected together in series. So we have multiple electric cells that are set up all together in a row, and essentially it just allows us to get a higher amount of current or voltage that we're needing. So the basic cell design, so basic battery design or basic electrochemical cell design, is composed of two electrodes and an electrolyte. So electrodes are solid electric conductors, okay? One electrode is marked with a positive, which is called the cathode, and that's in general. That's in reference to our voltaic cells, which we'll get more into later. And the other is marked as a negative or an anode. So we have our cathode and our anode. Now, each cell has at least one electrolyte present, okay? And electrolytes, as you might remember from Chemistry 20, electrolytes are aqueous electric conductors. Now, generally, it's some sort of ionic compound that's dissolved in water. It can be an ionic compound, an acid, or a base. Any entity that essentially can have the potential to conduct electricity. Now, when we talk about electricity, we need to think about what is electricity and what does it mean in terms of chemistry. Essentially, electricity, all that it is it's the flow or movement of electrons. So we have some sort of movement of electrons, which is electricity. Okay, now we need electrodes and electrolytes in our cells in order to have this movement of electrons. So electrons always move from the anode to the cathode. Okay, so always, our electrons move from our anode towards our cathode. Okay, this requires an external circuit. Okay, and an external circuit in this case will most likely just be some sort of conductive wire. Usually it's a copper wire of some kind. A voltmeter is a device that can be used to measure the electrical potential difference, which is the energy difference per unit of charge. So essentially, electrical potential difference is just our voltage. So we have a voltmeter to test the voltage, and essentially the voltage again is this difference between our two sort of cells that we're looking at, which we'll get into here as we go through. Oops. So electrical current is a measure of the rate of flow. So the rate is the amount in time, okay, that of charge that that goes past a point in an electrical circuit. So we talk about current as in amps. Okay, so we measure current is in amps, and we measure that with our capital A as in amps. Okay, the charge transferred by a cell or a battery is measured in coulombs. So we use a capital C to measure charge or coulombs. Okay, the power of a cell or battery is the rate at which we produce electrical energy. And no, this is watts. This is what you would see sort of on your energy bills that you get at your home, is sort of watts or even watts per hour, things like that. So the energy density of a specific energy of a battery is used to measure the quantity of energy stored or supplied by unit mass measured in joules per kilogram. Okay, so that's joules per kg. All right. Now, as a summary of everything that we just went through there, this isn't necessarily something that you're going to have to be super slick at, but it definitely is something to be familiar with. It will help you understand what is going on in our chemical cells. Now, the ones that I'm going to draw your attention to for sure is going to be current and voltage. Okay, so current and voltage are two that you should definitely be quite familiar with as we go through this unit. Now, current is I, okay, this is a capital I, and we use an ammeter to measure current, and the unit is in amps or amperes. Okay, we notate that with an A, and 1 amp is equal to 1 coulomb per second. Potential difference is voltage. Okay, we use the capital letter V, we use a voltmeter to measure it, our units is in volts, and 1 volt is 1 joule per coulomb. Okay, now these two units are the two that you should be very familiar with. Power, energy density, and charge are also good to be aware of, but it isn't something that you necessarily will see throughout our examples. I'm just going to skip over that. So essentially we have 3 main categories of cells that we can talk about here. The first is primary cells, and primary cells, in my chart here that I have sort of 3 general examples that we can talk about. We can initially talk about the dry cell. Okay, the dry cell is inexpensive, it's portable, we use them in like flashlights, radios, and other consumer items. Okay, we can also talk about the alkaline dry cell. The alkaline dry cell has a longer shelf life, and it has similar uses as the dry cell, but it definitely lasts a longer period of time. You'll notice the voltage between the two of them are identical. Okay, the mercury cell is a smaller cell. It has a constant voltage during its active life, and we use those in hearing aids and watches. So it's a very small cell, and it's very consistent voltage throughout. Okay, you'll notice it's slightly less voltage, but not a lot. Okay, now primary cells are are sort of most basic cells that we can talk about. Secondary cells are cells that can be recharged. So these cells, once you use them once, they have to be put sort of into a recyclable of some kind where our secondary cells can be recharged. So we have a nickel cadmium cell. They're sealed, they're lightweight and expensive, and they can be used in power tools, shavers, portable computers, things like that. We have our lead acid cell, really large currents, reliable for recharges, and we have them in vehicles. So this is why if you were to get battery acid in your vehicle on you, it could be pretty dangerous. You have acid in there, a very strong acid, so it's definitely not a good thing to have on you. Okay, again, secondary cells are cells that can be recharged. We have our fuel cells. Okay, fuel cells, we're dealing with either a hydrogen-oxygen cell or an aluminum air cell. Okay, now these are lightweight, they're high efficient. Okay, and we use these in some vehicles and space shuttles. Okay, and our aluminum air cell is and high energy density, made from available aluminum alloys, which are very common, and they're fairly efficient here. Again, you'll see a higher voltage here than in other examples that we've looked at, and that's an important thing in fuel cells because you need a great deal of fuel per se from those cells. Now, this is just our introduction into what electrochemical cells are, and there's a second part of this video that is going to be called standard cells. And we're going to look at sort of the general structure and nature of these electrochemical cells and get a deeper look as to what they are and how we can use them in chemistry. All right, at this point, if you need to go back and take any additional notes, you may want to do that now, and good luck.